Okay, so this is Burroughs Class C. I don't think these are super common. Basically, this is kind of like a clone of the electric comptometer. So it's a key-driven machine, sort of. It's basically the same usage as far as the keyboard as the comptometer. Like when as soon as you push a key, it adds it in. But instead of the key actually driving the mechanism, there's a motor inside that drives it. And it has a few additional features on the side. So I have already taken a look at the inside here. There's four screws, one in each corner, and then this should lift off. And back, as you can see, that's our motor back there, which drives this shaft which runs across. Punch and tone. This drives this, which is a funny little clutch. This one does not work. I have tried it and played around with it a little bit. Plug it in here. And how this clutch works is kind of interesting. So you see this thing on the back here? That's kind of like a cup shape with like a half round pin in the middle. And when you trigger it by releasing this little catch here, the pin in the middle, the half round pin, rotates into one of the grooves on the gear, and then that grabs it and spins it around. So I thought that was kind of interesting. I haven't seen that before in any of these machines. Unfortunately, it doesn't really do anything. Like if you hit plus, it didn't engage that time. There it goes. It doesn't want to cut off though. I think if one of these, this thing here, this is the switch, so if you pull this forward, now I think it should be off. Yeah. So if we turn this around to the front, you'll see that the register is a little bit jammed. I think if you push any of the keys, nothing actually happens. So like this one has a 1 in it. Let's try pushing 1 and see what happens. Yeah, nothing. So, definitely going to require some unsticking. I did do a little bit of the unsticking already, because when I first got this thing was completely stuck and it wouldn't engage at all. So I did manage to get that unstuck, and now that engages, but it doesn't actually accomplish any tasks. So definitely going to be a lot of grease glued parts in here. So I think what I'm going to do is start taking some of the covers off and see if I can figure out how this machine works and what's stuck, and see if I can start getting it unstuck. Other than that, there's not a lot I can say about it right now. I'm assuming this is going to be the accumulator kind of register where you hit numbers on here, they add right in here, and then this is probably like a storage thing where you can transfer this number up to here probably. But like I said, I don't actually know anything about how this machine works yet. So I think I'm going to work on figuring out how it works, and then I'll see if I can explain what's wrong with it. Okay, so I've completely disassembled the entire upper register. You can see some of the pieces here. The rest of the pieces are soaking in lacquer thinner to try and dissolve all the old dry grease that's on them. And I think that's going to be the main issue with this machine. This is one of the rods from there, and you can see all the dried grease. It gets like hard and powdery and glues everything together. So it was pretty hard to take that apart the way all the pieces were stuck on there. But it's apart now, cleaning the grease off of it. So I might have to do the same thing to the front register because that seems pretty stuck too. So usually these 40s and 50s machines that have this problem, whatever grease they were using back then, definitely does not do well long term. So place your bets now whether I'll get this back together. There's quite a few pieces, planetary gear sets and stuff that there you've got. These are the digit wheels themselves. and then inside of that goes this. It's still kind of sticky. Let's see if and that will fit on there. They're all kind of sticky. I'll have to show that when I get them cleaned up. But basically, that goes in here, and then you also get one of these that goes in. Not even showing it. That goes in, and you get one of these that goes in there, and then that's how it does the carry across. But I'll have to show that when it's all cleaned up and back together, I guess. So hopefully this is going to go back together. I mean, it should, but it's going to take a lot of figuring out. So anyway, I'll show you some more when I get the parts cleaned up and see if we can get this back together. Okay, so I've completely removed and disassembled the wheel register. You can see all the parts here. I cleaned them with a lacquer thinner to get all the old hard dried grease off. And you can see started putting them back together back there. The grease turned into like a hard white, almost like powder. I think I showed that before actually. So those have all been cleaned up, started putting it back together, but then I decided to turn my attention to the front register because I realized that actually the front register is the most important one because whenever you enter a number on the keyboard, it gets directly added to the front register, and then the plus and the minus buttons transfer that number to the back register. So like plus would add what's ever in the front to the back, and minus would subtract whatever's in the front to the back. So without the front register working, the machine won't work at all. So I decided to turn my attention to that, and unfortunately the front register cannot be removed. See, the back one came out because there's this plate, there's a clone of it here, and then you just take that plate off and then you can take it out. And then I just started on one side, sliding the pieces off the register. Because what happened is all of the wheels in there got glued to the shafts, so the way that it's supposed to come apart is you're supposed to just slide the shaft out from one side, and then all the wheels will, fall out. And that's how you're supposed to take it apart. But because every single wheel is glued to the shaft, you have no chance of ever pulling the shaft out from the side. So with the wheel register, I was able to take the whole thing out and then start on one side working the wheels off one at a time. Unfortunately, that can't happen with the front one because it's inside the actual main frame of the machine. So you basically have to take the entire frame of the machine apart and then try working it out from there, which I don't really want to do. So what I've been doing is, just trying to work it back and forth, a little bit, and we are getting somewhere. So let me just show you. We do have some signs of life now. If you watch this wheel, if I trigger it here, it should see it almost. Is that back all the way? Let's try it again. So each time is subtracting 9. What would happen normally is, so there's a piece inside here that has different pegs on it, and when you push a key, there's a piece on the bottom of the key that goes down, and then also when you push a key, it engages a clutch back here on the back shaft that throws that other piece forward until the pins on it hit the bottom of the keys. So if you push down 5, that would get thrown forward until it hit the bottom of the 5 key, and correspondingly that would also add 5 to the front register. Now because this is for the last column here, so there's no keys, so whenever you activate it just goes all the way forward, which is the same as adding 9, so that's why it adds 9 every time. This is the only one I've been able to free up so far. It took quite a while to get that one freed up. So if you look back here in the back, you can see this. So right here, let me see how I'm pointing it. This piece is a little catch. And when you push a key, it releases that catch, which engages with these gears here. There's a gear for each column. And that pushes the whole, it's kind of hard to just describe what the actual shape of it is. Let's see if I can, show this. So it's this piece right here. You can see there's one of the pegs, there's another one. So it's going to throw that forward until one of these pegs hits the bottom of the key, at which point the catch will disengage from the gear. And then when it disengages, a spring pulls it back, and as it pulls it back, it drives the wheel forward the appropriate number of positions. So let me unplug this and see if I can show that here. My tripod will cooperate, which it doesn't want to. So I think hopefully you can see the wheel there. So if I just push this forward a little bit, you see it engages, and then when I release the catch, it should spring back and drive the wheel. I can. See? So when I release the catch off that gear, then the spring pulls it backwards and drives the wheel for the appropriate number of positions. So, unfortunately I've only got one column free so far. So you can see here, these things are spring-loaded. And those are the carry counters. So what happens is, not counters, but the carry mechanisms. So there's a snail cam. I'll show you that on this somewhat register. This snail cam here rides against this, and as it rotates around, this snail pushes this out until it gets all the way out to the maximum. And when it gets out to the maximum, then it lets this go. This falls back and drives this wheel one position forward. So you see, with the snail all the way back, it's at 7. With the pin here all the way back, which would be equivalent to right before the drop off of the snail. And then when the snail drops off, that swings forward one position, and that's your carry. So, because these pieces are so complicated, let's see. I showed this before, but like this piece goes inside here. So there's friction. There's dry grease gluing this piece to the main shaft, then more dry grease gluing this piece in place in here, and then same thing with these pieces. There's dry grease gluing this piece onto the shaft, and there's more dry grease gluing this piece into here so that they won't rotate, and then these pieces are the ratchets, so that when the rod comes forward, it ratchets past and then drives in the return stroke. Well, these pieces are also glued to their intermediate shaft, which is right behind here. And then there's also these pieces. These right here are the spring-loaded ones. That one's still stuck. So these also get glued to their shaft. So it's just really a mess of everything being glued together. So I think what I'm going to do is see if I can free up some more of these. You can see this one's free, this one's free, this one is not moving at all, it wiggles a little bit, that one's not even wiggling. So it's going to take quite a while to get all that stuff freed up, but I'm going to try to see if I can get these freed up, and if I do, we can continue working on the back register, because it wouldn't make any sense to put a lot of effort into getting the back register assembled if we can't get the front register working, because this is the one that it adds to directly, so we can't use the back without this one. So I think we'll do that and bring you back if we have any progress. So we're getting somewhere. These three are pretty good. So we still have 100 in there now. If I press 5, it adds 5 in. To make sure that it goes all the way, because if this doesn't latch to the final position, the slider that slides down to engage it next time will block and stall out the motor. So you have to make sure that this latches in. So that added 5, we can add, say, 6. That's 11, that's right. Latched in that time. So I've got 1 over here now. So if I add 5 to that, I should have 6. Sure that latched in, that's good. Looks good. So yeah, getting better. Unfortunately, only these 3 columns work so far. This one is still pretty stiff. But yeah, so assuming that the rest of these can be freed up, we might be okay. At least for adding. I still have to work on clearing. I'm not quite sure how it clears it yet, but definitely a lot better than it was. I mean, these were completely frozen solid. You could barely even move them. You had to get a screwdriver in and pry them just to move it. But now the motor is driving the slider forward and it's returning under just the spring tension. So definitely a lot looser than it was. So now they seem to be locking in. That one didn't lock in. So there it goes. So sometimes it's sort of stuck a little bit, but definitely making progress, I think. I'm a little afraid to push these buttons. I think these are supposed to subtract 1, but who knows what they'll actually do. We could try that. Let's add 1 in there. And I'll get my cord ready to unplug just in case this stalls out the motor, because I have no idea what it's going to do when I push this. But it should subtract 1, I think. Well, it did that. A bit, not quite sure why the motor kind of took off there, but yeah, it subtracted 1. So definitely promising that these are freeing up, but it's a very, very slow process. Basically just, wiggling things back and forth. This one's getting there. We're working on that one. Yeah, very slow, very painful, but nonetheless, we are making progress here. Okay, so I've made some progress. See, all these are free now. What I did was, once I got down to like these last 3 or 4, I was able to pull the middle shaft out and then take these last couple out and clean them out separately. So these should all be free. So I've got this plugged in, so I should be able to do some addition here. Key still sticks, and these don't always return all the way, but so that one worked. Almost. What is this? Partially works anyway. Something is not quite latched to, I think. There we go. So those are supposed to lock when they're in their home position. So I'm going to add 3. Did it return all the way? I think it did. Looks like it did. So if I add 3 to that, I should get 6. And I do. I should be able to add 4. See, then it carries over. So a little bit stiff, but getting there. This one I might have to realize here. This number is a little bit lower than that one. This gear might be 1 tooth off on the drive, so I might have to readjust that. But definitely better than it was, and clearing usually works for something in that column. So you can see this column's a bit sticky, and this column's a bit sticky, but see, almost worked. Doesn't always switch off either. This one's still a bit sticky though. There we go. So these are spring loaded, so when it clears, it releases a latch, and then these all are supposed to spring back to 0. But because this one's a bit stiff, that's why it's not springing back. But other than that, definitely a lot better than it was. On the motor, on the governor, I can show you this. So you can see the governor down there. It's kind of hidden. So I'm not sure if you would be able to see this or not, but right here around this point there was a bunch of carbon tracking in here, and I think that was allowing the motor to overspeed. So if you notice this time when I was running, the motor is a lot quieter. I cleaned out as much as I could around there, and it seems like now the sparking is down here at the points where it should be, instead of burning up here where it was before when I had noticed. So we'll have to keep an eye on that and make sure that the carbon tracking doesn't come back. If it does come back, it's probably going to eventually consume this entire phenolic wafer here, at which point the governor will be useless. So if that happens, I'll probably have to, put a resistor or something in series with the motor, since the garden won't be functioning. But for now, clearing this out, the sparking is back down here at the point. So for now, at least it seems to be working. But I'll have to keep an eye on that. Additionally, I started putting my puzzle back together here. Come back up. So I started putting the upper register back together. But I misplaced. So if you see, I'm not sure you can see it or not, but see how this piece goes straight down and this piece has a chunk missing out of it? So the reason for that is this thing right here goes in where that piece is missing, but unfortunately I put it at the wrong place. So when this would actually go in here, we go in, I think it goes in something like that. I'm not sure if you can see, but I don't know how to see down there, but that thing that swings up is over here, but the register where the piece missing is over here, so I just have it one position off. So to fix that, I just have to take it apart up to here, which it looks like I need to take these two out. So these things here are the, I don't even want to call them carry delays, or so they're just a thing like this with a pin on it. And I can probably show you better once I have this all together, but basically what happens is the snail, which I can show you when I take this apart. So let me just take these two out of here, and then I need to take a bunch of, if I can get this shaft out, that would be nice. Go back to, I'll have to take those off, but basically, this snail here, see the snail kind of rides like this, and so the wheel will start in this position, and that's the 0 position, and then as the wheel rotates up towards 9, the snail pushes this out, and this takes up the planetary slack. So as this rotates around, it's constantly driving the planetary gear over to the next wheel. But what happens is this springs forward and takes up that rotation, so the next wheel doesn't actually turn until you get, so this is to move out, taking up the planetary rotation until you get to here, at which point this would spring back and drive the next wheel forward exactly one position. So let me get back on this. If I can get one of these out, I can show you the other mechanism. The other mechanism is this. So this piece goes on here, and then as this gear from this wheel drives this gear right here. So as the snail, it starts somewhere around this position, and then as it drives, slowly moves out until it gets to the end when this snaps back and drives the wheel forward exactly one position for the carry. So let me work on fixing this, and we can put this back together, and then hopefully I can show you in better detail how all that works. As you can see, I did kind of manage to get this back together. Unfortunately, the end of this shaft broke off, so I can't put the last 2 wheels on, so that's unfortunate, but nothing really I can do there. Aside from getting a new shaft, but I don't have that. These are pretty thin shafts, but I mean, for the job they do in the machine, it's not, you know, they're fine for that. It's just that when pieces get stuck on them, sometimes they're not made for that kind of stress. But anyway, the front register is 95% working. So I can add stuff in here. And it'll add up. Clearing sometimes works. So you'll clear, but then this gets stuck. And also this piece over here doesn't return to its home position. I'm not really sure why it's getting stuck, because it didn't get stuck before, but suddenly now it's getting stuck, so I'm not quite sure what the deal is with that, but pretty much every time now it gets stuck. So I don't know what's going on there. Transfer to the back register sometimes works. So we're just putting some numbers here. Those are numbers. And then we'll hit plus and we'll see if it works. Let's see, it only transferred the first 2, it didn't transfer the other ones, so. Part of the problem with the back register, and also sometimes the front register, is the timing. So all of the gears, and I think I've showed this before, but you've got, you know, all these, you know, this piece, and then each of these has 2 pieces. So, you know, this piece has to be timed right with this piece, which also has to be timed right with this piece, and then inside here, these 2 pieces have to be timed right. And then when you put them in conjunction with the other shaft, which, you know, consists of this ratcheting thing, which drives on here, this gear drives on here, and then these teeth in here are driven by the sliders from the columns. Everything has to be timed just right, and when it's not, things don't work properly. So, like for example, the transfer here, I think the reason why I only transferred these 2 is because these ones are stuck. See, it moves freely here, but I think the riser the riser that actually drives this forward, which you can kind of see, this thing right here, what's supposed to happen is when I hit the plus button, this is supposed to drop down in proportion to whatever numbers on its corresponding front register. But I think the timing is a bit out, and so this can't drop down, because it only drops down under spring tension. This spring back here is all that pulls it. So if it's out of time and jamming, see, it moves a little bit here, but I think when you try to go forward, it jams. Same thing with one of the other ones here. Sometimes, I think this one here, sometimes it'll drop down, but then when it tries to, you know, actually drive backwards to its home position, it jams and actually stalls out the motor. So I think what's going to happen is I'm going to call this good enough, because really the only thing that I can do is just repeatedly take this apart and put it back together until the timing ends up being right. Some of the things you can look at and see, you know, differences between column to column and see, you know, what might be at a time. But between this column, which works, and this column, which jams, I'm having a very difficult time finding any difference between those. So I think I'll just finish up this video with a description of how some of this stuff works, and maybe that'll help anybody else that's working on this machine. But I really don't think it's worth my time to spend hours and hours more on this, trying to get, you know, these minute timing differences figured out. Also, clearing on the back register doesn't always work correctly either. I can hit the button here. You see that? So that one also gets stuck. and this thing also doesn't return to its home position on the back register either. So I don't exactly know what it's getting stuck on. I can't really see anything that looks sticking in there. But pretty much every time now the front one gets stuck. And also this thing doesn't return to its home position there. And what this is this piece here, which is getting stuck. If you can see that. Basically what that does is it moves, you can see it moves this whole shaft back and forth across there. No, it's really stuck, I think. No, it's not. No, it moves. You can see it moving, right? Yeah, you can see that moving back and forth there. And what that's for is that's the overshoot protection. So what happens is when it clears it, it disengages that so that the digits can freewheel back to their home position, which is at 0. And then when it's engaged, it prevents the wheels from turning without the rocker being driven. So basically what happens is the rocker drives down and then the rocker stops according to whatever number you've pressed on the keyboard. But because the wheel has momentum, the wheel wants to keep going. So that interlock there prevents the wheel from spinning past the number that you've entered. So I think I can actually show this. If I will clear it, and now it's disengaged, so if I hit some of these numbers here, see I'll hit all 6s across, and you'll see that not all of them will display 6. You can see this one overshot, and that one overshot. So because there's no interlock there to prevent the wheel from spinning fast or spinning over what the slider has driven it. Here, this one gets stuck too, and I'll push this up with that. And then we'll make sure it's home, and now if I push all 6s, it'll actually display all 6s. And see, now we have all 6s on the front register. So, I'm not sure how much I've explained of this before, but basically what happens is, and I can probably actually show this a little bit better on the back register. Let me do that. So I've detached one of the risers here from its appropriate driver so I can just play with it a little bit here. So normally the riser is in its home position like this. And when you press the add button to add, the riser will drop back. You can see it as I'm releasing it there. You can see the ratchet, which is down in here, ratcheting forward until it hits a stop, which is predetermined by the number on the front register. Now for the front register, the stop is predetermined by whichever key you've pressed. So each of these keys have a little tab on the bottom of it, and the slider slides forward until it hits that tab. So like for 1, it'll only slide forward a little bit. For 9, it'll slide forward all the way until it stops, and that determines, that distance is directly proportional to the distance that the wheel turns. So what happens then is the slider returns to its home position. As it's returning, you can see it drives the wheel forward the appropriate number of positions. Now on the front register, the sliders are power driven forward and spring return. On the back register, they're spring driven forward and power return. You can see this bar right here drives them forward. Now the reason why this bar is back is because I've got the machine halfway through an add cycle, so that released this bar. So it's hitting on something there. Oh, it's hitting on the... It's getting a bit stuck. Which one? There we go. So I'm going to top down view here. So this slider, which you can see, engages on teeth down inside this little wheel right here. And I'll show you can see down in there. Right next to this thing, you can see the little tiny teeth down in there. And that's what this engages on. Now these other bigger teeth here on the outside, you can see those. Let's point to the right one. These ones here, those bigger teeth are the overshoot protection. So I think those latch in with the spaced out teeth on here. So let's see, this is correctly overshoot protected. So let's see. So yeah, so right now this wheel cannot turn at all, it's locked. And you see this thing twitching. I think that locks into these teeth and prevents it from being driven by this direction, but allows it to be driven from this direction. And that prevents overshoot because so normally it'll drive it, and see this wheel builds up momentum as you drive it, and then it'll try to drive forward, but the overshoot protection blocks it from going past. So, sorry, shaky camera, but so this slider drives teeth on this wheel, which is attached to a ratchet, which ratchets against this other gear on this side, and this gear drives this big ring gear on the actual digit. And then as the digit turns, it also has a gear sticking out this side and also that snail cam, which I think I showed before. And that snail cam pushes out on, I'm not sure if you can see it, there we go. So you can see this thing right here. This thing right here you can see is riding on the snail cam. And this piece also has teeth on it, which engage into the teeth on the bottom of these things. So these teeth on the bottom, actually I think this one looks like it's missing a tooth. These teeth on the bottom here engage with teeth on top of the piece that rocks back and forth, driven by the snail cam. So you can see as the snail cam drives this out, this piece right here rocks back. So you can see it rocking back, and then it jumps forward each time this cam here, or this pin here, falls off the end of the snail cam. So each time that falls off the end of the snail cam, this jumps forward, and that jump forward is what drives the next wheel forward one additional position. So if you watch, I'll do this slowly. You can see as soon as that jumps forward, it drives the next wheel forward one position. And it has to drive this forward one position because everything else here is locked. Like this gear is locked in place, so this can't turn. So the motion of this is directly transmitted into this motion, the motion of this going forward one additional position. So this gear drives on the inside of this thing. See, this thing is also locked in place. If I tried to move this out, it'll just drive the cam. So it's kind of hard to show this, but you'll watch as I turn this manually, the cam follower will be pushed out because this wheel is not turning, so this gear can't turn. So it has to go with the outer shell because this gear has another gear on the other side. I can show this where I put the other piece. Here. So you can see this is the big gear that you're seeing, and then on the other side it has a small gear, and those are attached to each other. So because this wheel can't turn because it's locked in place by the ratchet gear. So when I turn this small gear here can't rotate with respect to this wheel because this is locked in place. So what happens is it drags this thing along with it. This piece gets dragged along with it, and then the teeth on the bottom of that piece just push the snail out. So this is spring-loaded, basically. So anytime you have a carry, the carry is spring-powered. The spring pulls the cam follower back, which drives this forward, which drives the next wheel forward one additional position. And now normally, when this is driving, there's two motions that can happen here. The wheel can turn, or this cam thing can turn. But because this, each preceding one is spring locked into place, theoretically, if I would Let's see how I can show this. If I would jam this wheel, it's going to spring that back. You can see that happening there. See? So now, because I've jammed the digit wheel, all the motion is going into springing the cam follower of the previous digit back out. And there's only so far that can go because this cam follower has a positive stop that it hits against. So if these wheels are stuck, what's going to happen is it's just going to drive the cam follower of the previous wheel back out against the spring until it stops, and at that point, once that stops, and everything's jammed. But that's the basic operation of the carries and how it actually drives it forward. So I hope that made some sense. And then this one on the end, because it doesn't have a previous cam follower or anything, the inside gear, which would normally be this gear is what's on the other side of that thing. So this is in there driving the next wheel forward as the cam follower returns. Because this doesn't have that, this just has a gear fixed to a post, and this post is locked in place. So this can't turn against that because that's locked in place. Now, one thing that I also want to mention is for clearing, basically what happens is, there's some stuff going on the bottom that I can't really show, but on the top side what happens is this shaft rotates down, and what this does is this releases all of the ratchets that are in here. So when this rotates down, let me see if I have something thin that I can manually release it with. But you see the ratchet there, which drives this forward. If I manually release that ratchet, see if I can. I won't be able to see it very well. That's going to be kind of hard to see down in there to manually release it, but basically if you can manually release it, then yeah, my ice pick's too fat, it's not going to work. But when you release that ratchet, then this wheel is basically free. So what happens is it picks this up, this ratchet here, and what this does is this prevents the wheel from going backwards. So this is just a forward only ratchet. So that when this is driving, or when this is returning, basically it forces the ratchet to ratchet instead of driving the wheel backwards. If you didn't have that, then every time you went back and forth with this, the wheel would actually go back and forth, and then you would never get any numbers registered. So this thing here is what prevents the ratchet-driven gear from going backwards. That's all that does. And actually, the reason why I can't release the ratchet is because it only works when this is in the home position. So let me see if I can hold this in the home position somehow. Actually, what I can do is I can release the ratchet on this wheel, because this one is in the home position. So if I can get my screwdriver down in there, see if I can release this. It might not work. There's too many pieces in the way, I think. You have to release that and release this at the same time. Yeah, it's not going to work. There's too many pieces in the way. But basically, I'll probably push this down and make it manually go. This thing will drop down, and this thing has little fingers on the end of it, which go in there and poke all the ratchets to release them. And at the same time, they have little pieces on the tail here, which pull all of these ratchets back up and out of the way. And what that allows the wheels to do is it allows them to freewheel. And see if I can drop this down. In addition to that, it's also pushing the overshoot shaft over and out of the way, so that's no longer interacting either. So this is going to drop down like that, and now you can see these are free here, and this one's even starting to return. So now that releases all the wheels, so now they're all free. There's also on the bottom, which I can't really show, if I can turn it sideways, see if you can see. Now, because I didn't actually engage the clearing mechanism, I just engaged the top half of it. The whole clearing mechanism isn't in force, but there's also these hooks here. You can see, and what these do is when it normally clears, these will lock in, and they will pull these to a predefined point, which puts some tension on the, well, basically what it does is it rotates this, and you can see the cam follower springs out there. You can see it moving, look right down in here, you can see it moving out. And what that's going to do is that's going to put, some spring tension on the wheels, because those cam followers are spring powered, and that's going to want to make the wheels spring back into their home position. So I think that's, the main gist of this. Also, these things are driven by a shaft that runs all the way through across the bottom, and they have a little slot cut in them, so when the shaft drops down, it drives these forward and makes them interact with this. I didn't take video of me putting this back together because it was an incredibly frustrating process, but and it's still not right, but so I hope that makes sense as to how the register actually works. It's not a super simple, but it's not super complicated either once you look at what every single piece does. As far as the actual machine, how that works, like the rest of it, I can turn this on the side here. So it's kind of hard to see. Let's see if I can pull one of these things out here. So you can see these things right here, and what these things are is these move up and down in proportion to the cam followers on the front register. And you'll also see that there's another little piece in here, this piece, and this is what's directly attached to the sliders on the back register. So the front register, determines where these things are set at. They, if there's a 0, these are going to be all the way retracted in. If there's a 1, they're going to be out a little bit, and so on. And these stepped pieces in here is what determines how far back the slider to drive the back register can go. So when you hit the addition button, it releases the blocker on the back slider so that they can slide back because they're spring powered, and they're going to slide back until that little tooth in there, this little tooth right there, hits one of the steps on this thing, and the step that it hits is determined by its position. It rocks back and forth, which is determined by, you see it move a little bit there, see if I can, there you can see that one moves back and forth based on wherever the cam follower is on the front register. So the position of the digit wheel, because the digit wheel is what has the cam on it, you can see there's a digit wheel here, has the cam there. So the position of this, what number it's set to, determines how far out the cam follower is, which determines the position of these slider things, which in turn determines how far back the back register driver sliders can go, which is how it transfers the correct number to the back register. So if any of these are, screwed up in any way, then it's not going to work properly. Which I think maybe part of the reason why it's not transferring to the back register could be that, but I think the main reason is the timing with that that overshoot shaft is blocking the slider from driving the register instead of blocking the wheel from overshooting like it's supposed to. So I think I explained before how the front register drive works, but that's with these sliders here. So what happens is when you push a key, the key has a little tab on it, and that will hit against these things right here. So when you push a key, it releases a latch on the back of, so I can show those. So see if you can look in, actually it's going to be kind of hard to see. Let me turn this up real quick here. So there's a little latch right down in there. I'm not sure if you'll be able to see this or not. Yeah, it's going to be kind of hard to point out. But basically what happens is you see these toothed wheels here down at the bottom. When you push a key, it releases a catch that allows the that allows the slider to be driven forward by these toothed wheels. And the toothed wheel will drive it forward until one of these pins hits on the bottom of the tabs of one of the keys, and at that point, because the latches in the back are spring tension, that will release the catch on the toothed wheel, and then this bar will swing backwards under spring power and drive the front register for the appropriate number of positions. So let me see if I can show you. If I just put my finger in here, you can see when I push down on that slider, you can see that or not. It's supposed to spring back, but it's kind of sticky for some reason. It's probably sticky because it's actually still trying to be attached to those toothed wheels because the toothed wheels aren't being driven. So this is not, the normal case is the motor will drive the shaft forward based on those toothed wheels until it hits a stop, at which point the catch will release and swing backwards. But because the motor isn't driving it against my finger, there's no pressure to release the catch, so that's why it's not swinging backwards like it's supposed to. But I think you get the basic idea of how that works. Yeah, see that swing catches. So basically I'm turning the motor shaft as I'm doing that because there's no pressure to release that spring catch on that toothed wheel. So I hope that made some sense as to how this works. These little numbers here are supposed to be for subtraction, and I think all that they do is they add 9 into each thing here. Because there is no direct subtraction on this machine. As far as the front register goes, as soon as you hit a number, it adds the number in. So when you want to do a subtraction, you have to use the complements, which are the small numbers. And say you want to subtract, so if you want to do the complements, you used to do subtraction. Say you want to subtract 5, normally what you'd have to do is you have to enter, complement 0, 0, 0, 0, 0, 0, and then the complement of 5, which in this case would actually be 4, but because it's your complement number minus 1 is the number you actually enter on the small digits, but that's besides the point. The point is basically you'd have to enter all of these zeros ahead of the number you want to subtract. So they have these little buttons down here which allow you to, basically it does that for you, because if you see entering 0 is the same as entering 9, so pushing this button will basically force all the other columns to add 9 in for you so that you don't have to manually do that. I don't know if that feature actually works. Let me try that. So I'll just put this back in here, make sure he's going to try it out. So if I enter, say we'll enter 25 over here, just because I don't want to involve the funniness of these columns when I try this. So say I want to subtract 3. Normally what I'd have to do is I'd have to enter 0, 0, 0, 0, and then 2 on the small numbers, which is a 7. So basically what I would do is I would enter, so let's just try this. So I want to subtract 3, I want to 0, 0, 0, 0, 2. And you can see that I had 25, I subtracted 3, now I have 22. That's correct. So let's clear this. Maybe. And make sure this is correctly engaged, and then I'll enter that again, went to 25. And now what I should be able to do is enter my complement, which would be the small 2, and then push this button. And yeah, so you can see that added all the 9s for me, and now I have 22, which is correct. So that's basically what these little nubs down here do. I'm not sure what else wants springing back now. And this is also not engaging properly. But so that's a basic overview of how this machine works. All of the subtraction lever does, I think. I haven't actually tried this because I'm afraid something's going to jam if I do that. But all that this does is it switches the orientation of those risers on the bottom. So those stepped risers down there, those actually have two sides. Normally, the addition side is in line with the sliders from the back register, so that when you hit the add button, those stepped things add the appropriate number of digits to the back register. But when you push this back for subtraction, it changes the orientation of those so that the other side of the stepped slider engages, and that adds the complement basically. So like how each of these have a complement, like 8 complement is 1, 7 complement is 2, and so on. I guess that's backwards. 1 complement is 8, 2 complement is 7. But either way it's the same. This pushes those things down so that the complement side engages, and then instead of adding, say, 1, it would actually add 8 to the back register, and that's you get your complements back there. So we could actually try that and see what happens. Let's enter, let's clear the back first. And that seems kind of broken. Probably because this thing is not properly engaged. Let's try that again. There we go. So the back's clear now. So let's try adding 25. So let's do 25 over here and see if that works. Well, that would be a no. Why is that broken? Let's move over one column and try it over here. 25. Or does that mean they want to disconnect it so we want to reconnect it? Nope. It's broken now. Not quite sure what happened there. It's interesting. Anyway, I think you get the point of this. I think I'm going to quit on this machine because I really don't want to spend... I already spent a lot of time trying to get the timing as good as it is now. Took quite a few hours of trying different combinations of gears and different stuff. So I think at this point I'm going to give up on this machine. I hope that you were able to at least get some useful information out of this video as far as how the machine actually is supposed to work, even though this one isn't quite working properly. But I really don't want to spend, another how many hours trying to fiddle with the timing to get these 100% correct. Because sometimes what you can do is you can take this front bar out and then spread the wheels apart just far enough to, get maybe 1 or 2 teeth timing difference. But anything more than that, you have to basically take the whole thing apart, and the shaft only comes out one way. So, if there's a problem with, say, this wheel, I have to take the shaft all the way out and get all of these wheels ahead of it. So not only would I have to fix the timing that's messed up with this wheel, I'd also have to redo the timing on all these wheels and make sure that that's correct. So I'm really kind of losing interest at this point. So this video wasn't very good, I know, but hopefully at least someone will get some useful information out of this. If they have one of these machines that they're working on, or just out of curiosity to how these electric machines work, because this is actually the first electric comptometer style machine that I've worked on, and I was kind of interested to see how they actually do it. So this gives you an idea of how they do it, and if you have one of these, maybe we'll give you some information on how yours works. These levers here, I'm not sure what both of them do. One of them engages this thing in the front here, which prevents these first 3 wheels from clearing. So if you don't want to, if you want to clear the rest of this but keep these 3 intact, you can latch this down, and then that will affect that. So whenever you push clear, then you see this jump forward to engage there, and prevented these wheels from being cleared if they had numbers in them. But I think that's going to be it for this video. Like I said, I hope you were able to get at least some useful information out of this. So thank you for watching.